Well, good afternoon, friends. Today we start the reductions of the type Birch reduction. Now, in Birch reduction, the aromatic compound get reduced at 1,4 position. So 1,4 reduction. Now the benzene ring get reduced at 1,4 position. That means hydrogenation take place at 1,4 position. So let's see the reaction. Here the benzene in presence of sodium in liquid ammonia. Here the sodium in liquid ammonia reduces the benzene ring to 1,4 reduction reactions take place. So this product formation occur during this reaction. So we call this as a 1,4 reduction, and this type of reaction is called Birch reduction reaction. Now let's see more example of the Birch reduction reaction. The naphthalene on Birch reduction gives sodium in liquid ammonia. Here the Birch reduction gives this reduced product as like this. And if there are the electron donating group is present, it is present on unsaturated carbon. Again, there is 1,4 reduction, but the electron donating group present on the unsaturated carbon, and if electron withdrawing group is present on benzene ring, then it gives the product in which the electron withdrawing group is present on the saturated carbon. So let's see the reactions of methoxybenzene, that is anisole on Birch reduction, sodium in liquid ammonia, it gives 1,4 reduced product. So this product is obtained by using the sodium in liquid ammonia. So this reaction is called Birch reaction, the Birch reduction reactions. Now, if electron withdrawing group is present, like carboxylic acid, that is benzoic acid, on reductions by sodium in liquid ammonia, that is Birch reduction, and the electron withdrawing group is present on saturated carbon, and the electron donating group is present on unsaturated carbon. So these two products are obtained, means the reaction occur here with two different donating and withdrawing group is present, then two different product is obtained. So only the COOH group is electron withdrawing group, showing such a type of 1,4 reduction in which COH group present on saturated carbon. Otherwise, the aldehyde or carbonyl group in presence of sodium in liquid ammonia, first they get reduced to alcohol and it becomes CH2O minus, and that CH2O minus means C double bond OH group get converted into CH2O minus type of group, and this is electron donating group, and therefore it is present on unsaturated carbon. So here in the Birch reductions, the sodium in liquid ammonia are consist of the electrolyte salt. So the transfer of electron take place, means reduction is carried out by transfer of electrons. So the sodium and ammonia form the salt. That salt is so NaNH3 plus and electron. So the salt is the electrolyte salt. So here is X times. So this electrolyte salt formation take place and the electron transfer occur. So let's see the mechanism of these reactions. I think we have already studied the mechanism of Birch reduction reaction in the metal dissolving in a solvent, that means sodium in liquid ammonia. We already seen the mechanism of this reaction. So let's see again the mechanism of this reaction. So let's see the mechanism of this anisole, and here the electron transfer takes place. So electron transfer occur at the ortho position. So why there is at ortho position? So find this electron. So we can show this as this electron transfer at here is what shifting here, and there is negative charge and electron are apart from each other, means less repulsion between that. So we obtain such a radical with negative charge species. Here is double bond OMe and it is also double bond. Then there is a liquid ammonia protonation of that carbanion, such carbanion protonated by liquid ammonia, then NH2 minus, and as the electron are lost by the Na, so there is Na plus and loss of minus NH2. Then another electron are transferred. Here is HOMe. Another electron is transferred here, generate the carbanion and carbanion on protonation. OMe, carbanion in protonation with ammonia, so it takes the proton and H2 minus and minus NH2 is lost. So the product obtained is 1,4 reduced product, that is this product is obtained. Now let's see the more example of Birch reduction reactions. Now both the electron donating group and electron withdrawing group present on benzene ring. So let's see the example.
Photons do not interact with magnetic structure. They are chargeless particles. They will not interact.
OCH3 as well as electron withdrawing group COOH. Now in presence of sodium in liquid ammonia, see here, these are electron withdrawing group and these are electron donating group. So 1,4 reduction take place and OMe group present on unsaturated carbon and COOH group is present on saturated carbon. So this product 1,4 reduction product is obtained. Now let's see second type of reduction reaction, that is Woods reduction. Woods, not Woods. Wolf-Kishner reduction. Woods is the reaction in which coupling of two alkyl halide by using sodium takes place. Now we take the reduction reactions. So here we take the reduction Wolf-Kishner reduction reaction. Now in Wolf-Kishner reduction reaction, the carbonyl group gets reduced to hydrocarbon by using hydrazine and in alkaline conditions. So let's see the example. Next reaction is Wolf-Kishner reduction. So in Wolf-Kishner reductions, by using first step is formation of hydrazole with hydrazine, and second step is KOH in ethylene glycol, so that there is formation of this hydrocarbon. So cyclohexanone is converted to cyclohexane. Cyclohexanone is converted to cyclohexane. So let's see the mechanism of this reaction. Double bond. So hydrazine NH2 NH2 from the lone pair of nitrogen attack on carbonyl group. There is OH, O minus, it takes the proton from the nitrogen, NH, NH2, and here loss of water molecule by heating.
provided
It
you
gives N, NH2,
from area
this
to
type of the hydrazone derivative.
directly proportional to the number of
Hydrazone derivative.
on each scatterer.
And in presence of KOH, this KOH is the base abstract the proton, formation of shifting of this protonated electron here to form nitrogen nitrogen double bond, and there is generation of carbanium and double bond NH. Here is carbanium. This carbanium on protonation. Here is H and double bond NH. Again, in presence of base, this base abstract the proton, this bond shifting here, and again there is generation of another carbanium. Okay, so plus N2 is eliminated, and again in protonation it gives cyclohexane. So this product, or this is the mechanism for the conversion of cyclohexanone to cyclohexane. And this reduction is called Wolf-Kishner reductions. So these reductions occur in basic medium. The reduction takes place in the basic medium or in the alkaline medium. Okay, let's see more example of this reaction. In presence of NH2 NH2 KOH, NH2 NH2 KOH, this get reduced to alcohol. So there is OH CH2 CH2 CH3. So this type of alcohol is formed. Then another example of Wolf-Kishner reduction is CHO OH, and here is CH2 CH2 OTHP, protected alcohol. Again NH2 NH2 KOH. So this aldehyde get reduced to hydrocarbon. So the product form is CH3 CH2 OTHP, and here is OH CH3. So this product is obtained, that means carbonyl group get reduced to hydrocarbon by using Wolf-Kishner reduction reactions. Okay, so another example, let's see more example in which there are carbonyl group as well as amide group present selectively. The amide does not reduce, but the carbonyl group get reduced by using hydrazine in KOH. So let's see the example of this reaction. And walk protected. Then C double bond O, here is ET. CH2 C double bond O N. Again there is, so this is the another type of. So here is amide. This carbonyl is being present with nitrogen, so it is amide linkage, and this is carbonyl. So in presence of NH2 NH2 hydrazine and KOH, selectively this carbonyl group get reduced to hydrocarbon, and the amide does not get reduced. So the product form is N
for your
Bok.
kind support and cooperation. Now I am going to
So these
end
get
this
converted to
meeting.
hydrocarbon. Here is ethyl
Participants
group
are
remain as it
requested to
is.
rejoin for 4 o'clock. Thank you, one and all.
C double bond O, and